Alright guys, so this is the section 8.4 video, and section 8.4 is the last of section 8. I know it's super duper short, it's the shortest one we'll do all year. And this is just kind of a hodgepodge of proportionality theorems for triangles. I mean, it's, each one of them you do set up a proportion, so I don't want to say it's unrelated, but it's just kind of hit and miss as far as why they put them in here, other than they have to do with ratios and proportions. So the triangle proportionality theorem here says if a line is parallel to one side of the triangle, so if this line here is parallel to here, then we can set up a proportion. It cuts it proportionally. So if I say if this is A, this is B, this is C, and this is D, it cuts it proportionally so that A over B is equal to A over B is equal to C over D. Okay, but and the converse of this is also true. So here we're saying, once again, if this is A, this is B, this is C, and this is D, we're saying if A over B equals to C over D, then QS is parallel to TU, okay? So same thing, just the converse of the other. All right, so let's do example 1 here. It tells us that QS and UT are parallel, okay? And then it gives us these lengths here. And we want to find the length of RQ, so I'm just going to call it S. Now, since these two are parallel, I know that we can set up a proportion. Okay, so I can say x over 9 equals, so x over 9 equals 4 over 6. Okay, and then from here, I cross multiply. So 6x equals 9 times 4 is 36. Divide by 6, I have x equals 6. Okay, so the length of RQ is 6. Go ahead and try example 2 on your own. This is the same as the one we just did, and then we'll go over it. So use example 1 as a reference if you need. All right, don't freak out on me if you got something that wasn't a perfect number, but you would set it up like this. There's several different ways you can set it up, guys. You could have set it up 44 over 35 equals 36 over x2. Okay, there's several different ways you can do it. There's other ways than just that too. But what you should have ended up getting, if you set it up correctly, is roughly 28.6. It was a big, long, messy looking decimal. If you wanted exact, the fraction is 315 over 11. Either one of those would work. All right, let's look at example 3 now. It says on the shoe rack shown, BA is 33, CB is 27 centimeters, CD is 44 centimeters, and DE is 25 centimeters. Okay, explain why the shelf is not parallel to the floor. So we want to show that this is not parallel to this. Okay, well, if it were parallel, these would be proportional. So if it's not parallel, these are not proportional. So I'm just going to set up a proportion. Okay, I'm going to say 27 over 33 equals, I'm going to have a question mark. We know it's not, but we're checking, 44 over 25. Okay, so we're going to solve this the same way we would if there was an x. I'm just going to cross multiply. So 33 times 44 equals, with a question mark, 27 times 25. Now, 27 times 25 is 675. And 33 times 44 is 1452. So clearly these are not equal, and therefore they're not parallel. All right, this is very similar to example number 3, so I'm going to let you try example 4 on your own, and then we'll go over it. All right, so if you work this out, you would set up a proportion, and you can set this up several different correct ways, but I set mine up 50 over 90 is equal to, and I put a question mark. I always put a question mark when I'm guessing because I don't know. So 50 over 90 is equal to, with a question mark, 40 over 72. Okay, so that's right here. And then when I cross multiplied, I got 40 times 90 equals 50 times 72. And then I plugged it in my calculator. I got 3,600 equals 3,600. That is a true statement, so they are proportional. And therefore, yes, PS has to be parallel to QR. All right, let's talk about the triangle angle bisector theorem. Okay, it says if a ray bisects an angle of a triangle. Okay, so this here has to be an angle bisector or we cannot use this theorem. So notice in this diagram, it shows me that this angle and this angle are congruent, indicating that this is a bisector. Then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So that is a mouthful and hard to understand. So I'm just going to say this is A, this is B, this is C, and this is D. Okay, so if I know we have an angle bisector, then I can say A is to B as, so A is to B as C is to D. It cuts it proportionally. All right, let's look at example 5. Okay, it tells me in the diagram angle QPR is congruent to angle RPS. So this angle here is congruent to this angle here, which indicates this is an angle bisector, so I can use that theorem. Okay, I'm going to call this A, this B, this C, and this D like my last time. Okay, so I know A over B equals C over D. All right, so now I can just substitute. I don't know A. We'll come back to that, guys. I know B is X equals C is 7 and D, I didn't mark it, is 13. Okay, so we have this whole thing is 15. And I know this piece here from here to here is X. How do I find this length? What expression do I have that represents this length here in red? Okay, guys, wouldn't this be 15 minus X? This whole thing's 15, and this piece here is X. This is whatever's left over of 15, so 15 minus X. Okay, so 15 minus X. Some of you are thinking, oh my gosh, we have two X's, what do we do? Don't freak out, we solve this just like we've solved every other thing. Okay, we're going to cross multiply. So I have 7X equals 13. Don't forget to put this in parentheses, 15 minus X. Okay, so 7X equals 13 times 15 is 195. 195 minus 13x. Okay, plus 13x plus 13x. I get 20x equals 195. Divide by 20, divide by 20. I get x equals 9.75. Okay, and that would be the length of RS. All right, we have one last theorem to cover here, and then we'll do an example problem, and then we'll be done with section 8.4 and done with chapter 8 completely. It's the three parallel lines theorem. It says, if three parallel lines intersect two transversals, then they divide the transversals proportionally. So if this length here is A, this length here is B, this length here is C, and this length here is D, I could say A over B equals C over D. Okay. All right, so let's put that theorem into action here. All right, it says in the diagram, angle 1, angle 2, and angle 3 are all congruent. Right, well, if angle 1, angle 2, and angle 3 are all congruent, that has to mean that all 3 of these are parallel because they're all corresponding angles. Okay, so that tells us that these 3 lines are parallel. Okay, GF is 120 yards, DE is 150, and CD is 300. We want to find the distance HF. Okay, well, we can't jump straight there. We have to do another step first. Okay, first thing we have to do is find GH. I'm going to call it X. Okay, so I can say 120 is to X as, so 120 is to X as 150 is to 300. Okay, now I have a proportion. I can solve that proportion. So 150 times X is 150X equals 120 times 300. If I put that in my calculator, 120 times 300, I get 36,000. That's a lot. Equals 150X. Solve for X, divide by 150. I get X equals 240. So this here is 240 yards. Okay, now the question was find the distance HF. Okay, this goes back to chapter 1. Hopefully you guys can do this by now. So HF would just be 240 plus 120, which is 360 yards. And that would be my final answer.